We're going to look at 1 through 9 today. Number 1 gives us a multitude of things going on. PM and N are all mid-segment. So that means DP is equal to PF, FN is equal to NE, and EM is congruent to MD. So we're going to use our different properties right here given this information. So they want to give us the following. They say NP is going to be parallel to what line segment? So we could choose two things. It could be either, DM, ME, but ultimately we can just do the entire segment and it's going to be parallel to PN just to show the entirety of it. So using the mid-segment theorem, we would have just the following DE. So line segment DE would be parallel to NP. And that's mostly an eyeball thing too. You could see right away PN goes in the same direction as DE. Okay? So that was number 1. Number 5, we're going to be taking a look at this through just a little bit more of a algebraic thing, but first we're just looking at the concept. So first we have MK is equal to 22. We want to find the length of VU. As you can tell by the tick marks, V and U is a mid-segment. If we want to use the mid-segment theorem, we can see right here that MK, or VU, is equal to 1/2 of MK. Well, we're in luck with this theorem itself. We are looking for VU. So we're going to plug in the information given. We don't know what VU is equal to 1/2 of MK, which is 22. Right here, we're just looking at this. VU is equal to 1/2 of 22. And then you get from here that it's 11. So VU for number 5 would be equal to 11. And if you're given whole numbers like this, you can just eyeball the answer. If you're seeing 22, you can just half that and get you 11. And if you're given 11, you can just double it to get you 22 and do the inverse. This is the algebraic way. But again, you can always eyeball these answers if needed. But we're going to see that when you have to do it the algebraic way with number 9, and that'll be the final one for today. So if we look at number 9, we have mid-segment RS. If we're going to call, the mid-segment is always going to be half of the third length of FH. So when we look at this, we have the following information. We know that RS is equal to 1/2 of FH. So this is the standard formula, but let's rearrange it because I think there's sometimes an issue with distributing with half. So what we're going to do is we're going to do the inverse of half to put it onto the other side. So let's multiply both sides by 2. So we have RS is equal to 1/2 times FH. We want to multiply both sides by 2 just so we can get rid of that half, because 1 times 2 is 2, 2 divided by 2 is 1. So we're at 2RS is equal to FH. Now I think 2 would be a much easier way to start it. This and this, they're the same formula, just different look of it. So I think this one is an easier one to focus, just saying that the mid-segment is 2 times the mid-segment is equal to the third segment of FH. So what I'm going to do is plug in the information. We have 2, and then we're going to do times 2x minus 1 is equal to FH, which is 2x plus 10. The goal of this problem is to find x. So now we have this equation set up. All we have to do is simplify and solve. First, distribute the 2 to 2x, 2 to -1, so you get 4x minus 2 is equal to 2x plus 10. And from here, we're just going to do our inverse operations because we can't combine our coefficient and constant. So we look at this. The first thing we should do is subtract 2x to both sides. The reason why I'm doing that is I don't like working with negative coefficients. So we have 2x minus 2 equals 10. From here, I know I need to get the constants together. So we have a -2 on the left side. So what I'm going to do is add 2 to both sides. We have 2x is equal to 12, and I don't have much room, so I'm going to move that equation over there. So we have 2x is equal to 12, and the last thing we need to do is just to isolate x. The way we're going to isolate x is we're going to do the inverse of multiplication, which is division. Divide by 2, divide by 2, you get x is equal to 6. And the way you can always check your answer when working with these is plug x back into both of these equations. And if FH is twice the size of RS, then you did the question